Okay, here's what's happening. We want to find a formula for the slope of PQ. That's the change in y divided by the change in x as we move from the point 2, 1, which is the fixed point, to a point a little to the right or left of 2, 1. So that would be f of 2 plus h minus f of 2. That's the change in y over the change in x would be 2 plus h minus 2. Here's all the calculations. I'm not going to go through each one, but this is the change in y resulting in this. I'm sorry, that's f of 2 plus h. Here's f of 2. If I subtract them, I get this. There's delta y right there, or the change in y. And the change in x is just h, 2 plus h minus 2. So if I put the change in y over the change in x, notice that I factored out this h from the change in y. These h's cancel out, and there is a formula for slopes of secant lines to the graph of that original function, 1/2 x squared minus 1. So that means the slope at when h is 0.5 is 2 plus 1/2 of 0.5 of 1/2. I'll write it that way. So that's 2 plus 1/4, or 2 1/4, or 2.25. Okay, now let's go to Desmos and see exactly what's happening here. I'm going to hide this part of the graph. Move this over here. And this line right here, or this point right here, is allowing you to see the slope of a secant line from P to Q. And this moving point is Q. This blue line is the secant line. The dotted green line is the tangent line. And you can see as h gets closer and closer to 0, that blue line is getting closer and closer to the slope of the tangent line. You're supposed to find the slope when h equaled 0.5. There it is, 2.25. And as we get closer and closer to that line right there, or that point right there, the fixed point, the slope is getting closer and closer to 2. Okay, and that's actually what it is. And you're going to learn that you can find that value by finding this difference quotient, we call it, taking the limit as h approaches 0. That's called the derivative. And if we think about that 2 plus 1/2 h, if we take the limit of that as h approaches 0, just substitute 0 in for h, and there is the slope of the tangent line. At the point 2, 1. Okay, and this expression right here is called the derivative of the original function. Okay, there you go. Hope that helped. You can pause the video and try to duplicate all these steps. Make sure you understand. There you go. Hope that helped.